Hello students, today we are going to start our lecture number 4 of module 2nd of subject nuclear physics. Nuclear physics subject have subject code PHCT 241. Now in yesterday's lecture we saw that high germanium purity detector, next bubble chamber, cloud chamber, and in today's lecture we are going to study spark chamber with shell models. Means in today's lecture we are going to start our second topic of second model, which is nothing but nuclear models. Now see here first, spark chamber. This is one another device for visualizing the track of an ionizing particle. Construction of this spark chamber is very simple. As I explained in yesterday's lecture, we already saw cloud chamber and bubble chamber. The cloud chamber and bubble chamber are also the gives the same working or same principle, that cloud chamber and bubble chamber are also used for finding the track of an ionizing particle. Now see here in today's lecture, spark chamber. Spark chamber construction. In spark chamber, there is a stack of parallel metal plates arranged with small gaps between them inside an enclosure filled with some noble gas, example neon, at a pressure of about 1 atmosphere. Means the spark chamber is nothing but in one enclosure there is a parallel plates which are stacked, and the total arrangement means the total parallel plates which are connected are placed in the mixture or noble gas. Okay, these plates are having several square feet in area, spaced about 1 centimeter apart in chamber. This chamber is filled with neon or argon gas mixture with helium gas at atmospheric pressure. Same as I explained above, the plates are several square feet in area, spaced about 1 centimeter apart in a chamber. Means that parallel plates are placed in that chamber, and that parallel plates having area nearly equal to several square feet, and about that plates are placed in that chamber about nearly 1 centimeter apart. This chamber is filled with neon or argon gas or a mixture with helium gas at atmospheric pressure. Means that chamber is filled with the inert gas, neon or argon, or with a mixture with helium gas. Now, all the plates are isolated from each other. First, third, fifth, etc. plates are grounded, whereas second, fourth, sixth are connected to high voltage direct current pulse generator, which gives them potential in short bursts of the order of microseconds. Means in that parallel plates which are placed in that chamber, the parallel plates alternatively connected. Means the first, third, fifth are grounded, whereas second, fourth, fifth are connected with the potential, high potential किंवा high voltage direct current pulse generator. Now see here the diagram or figure of the spark chamber. Now in that, see, as the external particle is enter, that particle is first came from this PMT. After that comes in this parallel plate region, and from that it comes out from the parallel plate region and goes here. Now see the some working. How it shows. If a high voltage is suddenly applied to the gap between a pair of parallel plate shortly after an ionizing particle has passed through the inert gas between them. Means if a high voltage is applied to the gap between a pair of parallel plates, as we saw, the plates are alternatively connected. Means if a high voltage is suddenly applied to the gap between a pair of parallel plates shortly after an ionizing particle has passed through the inert gas between them. A spark jumps along the path of the particle. As that particles goes through that inert gas, then there is a spark will be occur. If a number of such gaps are stacked vertically and operated simultaneously, the track of the particle is defined by a line of spark. As that particle, as that particle goes through the parallel plates, means goes through the inert gas, here is the inert gas is filled. If that particle goes through the inert gas, then it will use the spark, means as this comes from these two here, then it will give the sparks, means there is a some line of the spark. Now this line of the spark can be observed directly or by video projection. Now how it will work, show from the figure. The spark chamber is stack of parallel plates which sandwich between two plastic scintillation detector. See here, this is a parallel plate, okay, and that are in between these two PMT. Okay. Now when a cosmic ray penetrate both scintillation, here we say cosmic rays, but that ray may be anything. Okay, means any radiation, maybe gamma, alpha, beta, means any particle. Okay, means when a cosmic ray penetrates both scintillator, a fast coincidence signal is produced to indicate that the particle has passed through the apparatus. That signal in turn triggers the high voltage pulse generator, which delivers a 7 kV pulse to alternate plates of chamber within 1 microsecond of trigger. Means what? When that particle goes through that PMT and enters to here, after that it goes to the high voltage pulse generator. Means when that particle cosmic rays comes from here and goes out from here, first one that this gives the spark, line of the spark. After that this goes to the high voltage pulse generator, and which again gives to the alternative, that voltage pulse generator means high voltage again gives to the alternative plate of that spark chamber. Okay, now next point is nuclear models. Now see, while studying nuclear physics, several questions are arises such as, why do nuclei emits alpha particles and beta particles? Second one, why the binding energy per nucleon is constant? How to explain excited state of nucleus? Such many more questions are there. Now, in order to answer these questions, we must study the constitution of nucleus. We must know the nature of nucleus. Hence, it is important to study the nuclear models. Now, means why we are going to study the nuclear models? Because when we are studying the nuclear physics, many more questions are arises, such as why there is emission of alpha and beta particle, why binding energy per nucleon is constant, and how we can explain the excited state of the nucleus. For such several questions, to give answering that questions, we should have to study the nuclear models. Now the first one is a shell model. See here, if we consider several nuclear properties, then we realized electron in atom and nucleons in nucleus both are having analogous situation. Exactly, as atoms consider an electron which are revolving around the nucleus, same means atom consider an electron, same nucleus in the nucleus. Okay, both are having analogous situation. Nuclei having equal to the particular numbers like 2, 8, 20, 28, 50, 82, 126, 184 are having high binding energy. That is, these nuclei are stable nuclei. This is very similar to fact that atoms having number 2, 8 are stable atoms and are known as noble atoms. Numbers of neutron or atomic number equal to several figures which are given above means 2, 8, 20, 28, 50, 82, 126, 184 are known as magic numbers. Okay, means why these are magic numbers? Because for that particular values or for that particular numbers, we saw that the nuclei have high binding energy, means they are highly stable. Now, what is the evidences of magic number? Means there are magic numbers as present. What is evidences? First one, Mayer suggested that nuclei with a magic number are abundant in nature. Second, helium and oxygen are particularly stable because atomic number of helium and oxygen are equal to 2 and 8 respectively. These numbers are equal to the magic number. As we saw earlier, as we learned that helium and oxygen are stable atoms, means as the helium has Z equal to 2 and oxygen has Z is equal to 8, these are magic numbers. That's why helium and oxygen are highly stable. Now, no more than 5 isotones are occurring in nature for any except n is equal to 50 and n is equal to ETT, which are figures from magic numbers. Means for the atom having neutron number n is equal to 50 and another one atom for which n is equal to ET2, these two atoms having more than 5 isotones, but except these two, no element in that periodic table have the isotones more than 5. Okay, now see here, SN Z is equal to 50 has 10 stable isotopes, whereas Ca calcium Z is equal to 20 has 6 isotopes. Again, this Z is equal to 50 and Z is equal to 20 are magic numbers. Okay, it is found that some isotopes are spontaneous neutron emitters when they are in excited state. Means some isotopes are spontaneous neutron emitter when they are excited state. See, as we saw in here, as Sn has Z is equal to 50 has 10 stable isotopes. Means like Sn, some of the isotopes are there which are having spontaneous neutron emitters when they are in its excited state. Now, the doubly magic nuclei means for Z and N both are magic number, like helium, oxygen, calcium, Pb are having very high binding energy. Means when the Z and N means proton number and neutron number both are same, that atoms or that nuclei we are seeing that doubly magic nuclei. For that doubly magic nuclei having high binding energy, as that doubly magic nuclei have high binding energy means they are more stable. Next point, alpha decay energies are having discontinuities at n is equal to 126, which is again represent magic numbers. Means when there is alpha disintegration or alpha energies, when we draw the graph of alpha energy, we saw that there is a discontinuities when neutron number is equal to 126. Same thing is occur when there is a beta decay also. Low neutron number capturing probability for nuclides having n is equal to 80, 50, 126 is also shows relationship between magic number and stability. Same low neutron capturing probability. For the nuclides having neutron number n is equal to 80, 50, 126, that nuclides having neutron number is 80, 50, 126, it shows that nuclides have low neutron capturings. Nuclei with magic number or nuclei with magic proton number Sn and Pb have smaller capture cross section than their neighbors. Similarly, as we saw in above point that for neutron number equal to 80, 50, 126, for such nuclei have low neutron capturing. Similarly, when neutron number is equal to n is equal to 80, 50, 126 means n is equal to this number, then that nuclei have small capturing cross section as corresponding to their neighbors, because corresponding to this that neighbors neighbor's number means that neighbor's neutron number is not magic number. That's why that neighbor's number is not magic number means they have high capturing probability as compared to the SN and PP. Now next one, the binding energy of the next neutron or proton after a magic number is very small. Similarly, as the neutron and proton number are magic number for one nuclei, consider any one nuclei, for that neutron and proton both are magic numbers, then the neighbor means suddenly close to this have very small binding energy. Okay, means neighborhood of that magic number have very small binding energy. Electric quadrupole movement shows sharp minima for these magic numbers, shows nuclei are having spherically symmetry and follows the magic number hypothesis. Means when we are considering the electrical quadrupole movement of that nuclei, for such nuclei which are having Z is equal to magic numbers, shows nuclei are having spherical symmetry. As we know that the nuclei are having spherical symmetry, means for spherical symmetry already we studied that electrical quadrupole moment is equal to 0. When electrical quadrupole moment is equal to 0, then obviously that shows sharp minima peak dip. Okay, that's why this follows the magic number hypothesis. Means we saw that when the nucleides have magic number, then there is a different properties. Okay, like that they have different number of isotopes, high binding energy, high stability. Okay, such type of properties are there, and that numbers which are giving that properties, that numbers is called magic number. Now, here means shell model of the nucleons of an atom are conceived to fill up shells in which nucleons with mutually opposite spin pair of these filled shells constitute an inner core and are in ground state. Similarly, as we know that when there is a electron, when we are write the electronic configuration for atom, we are writing same as when we are writing electronic configuration of atom, we are say that that is a closed shell to the nucleus. Okay, similarly we are here when we are filling the shell of that nucleus, we are also got the inner core and the ground state. Okay, means here also we are filling that nucleons in the nucleus within the different shells. Okay, and that we are going to study, okay, in our next lecture. Now see, the valence nucleus in the unclosed shell move in the average potential of the nucleus, move independently in the inner core. Therefore this model is also known as single particle model. As we know, the valence nucleus in the unclosed shell, as the valence nuclei in the unclosed shell move in the average potential, means the shell which is not close to that, not closed, that is called unclosed, and the nucleus in that unclosed means the at a very small distance, that shell is at the small distance, mean when that the nucleus in that shell moves in the average potential of the nucleus moving independently in the inner core. Therefore, this model is also known as single particle model. Okay, because of this fact, spin and magnetic moment of even nuclei is 0. As we are feeling that the number of nucleons in that shells as its opposite spin pair, means one in upstate, another in downstate. As we are feeling in that manner that one is upstate, one is downstate, due to of that spin and magnetic moment of even nuclei is 0. Means when Z is even, N is even, then total A is also even. When the A is even, then as we are applying, as we are filling that nucleus in, one is upstate, one is downstate, mean there is a total cancellation. Means after placing all that nucleons on the basis of that spins, then at the end the resultant spin of that nuclei is should be 0. Okay, Understand, student? Okay, thank you.